Hey guys, welcome back. I know this has been a really long time coming, but things have finally come together so I can show you guys how to put together a MintyPi. These are all the parts that we're going to use for this, and believe it or not, it's all going to fit inside this Altoids tin. First, you're going to need, of course, an Altoids tin. Raspberry Pi 0W. The 0W is really nice for projects like this because you get Wi-Fi and Bluetooth without having to have any extra hardware. I've got a set of Helder's custom parts for this, which includes a button PCB that already has the start and select tactile switches attached to it for you. And something new since the last version of this board that I showed off, now we've got test pads on the back. So once you have everything attached, you'll be able to really easily test and make sure that you have a good solid connection between each of these pins and the pinholes on the Raspberry Pi. A 2.4-inch screen, ribbon cable, and then this board for the screen connects to this ribbon connector, and then the ribbon cable goes from this to the button PCB. So yeah, great job by Helder. These custom parts came out fantastic. I've also got a set of the 3D printed parts that I designed. I have these for sale, but if you do have access to a 3D printer, then be sure and check out the written guide that goes along with this video, because I'll have links to the STL files, so you'll be able to download those and print these out yourself if you want. Got a USB sound card. I chose this particular one because it actually puts out enough juice to drive a tiny speaker pretty well without a separate amplifier. In fact, I did some tests and found that this was actually louder than a Game Boy Micro, which is good enough in my book. The speaker that goes along with it is 0.5 watts, 8 ohms, and is 20 millimeters in diameter. But the more important measurement is the thickness. It needs to be 3.5 millimeters or less so that it can fit between the 3D printed part and the button PCB. Battery charger. For this, I'm using the Micro LiPo from Adafruit. It's a lot cheaper than the Power Boost, and since this doesn't step it up to 5 volts like the Power Boost does, you'll actually get a little bit better battery life using this option instead of the Power Boost. But if you did go out and get a Power Boost for this project, don't worry, you'll still be able to use it for this if you want to. 1200 milliamp hour lithium polymer battery. This one is from Adafruit as well. I like their batteries, I trust them, but you can find batteries from other manufacturers on eBay and Amazon and stuff like that. A power switch, 2 tactile switches for the L and R buttons, and then we've got a set of DS Lite buttons with the rubber membranes that go along with them, and some screws to hold everything together. There are a couple other odds and ends that you'll need, like some wire. I get asked about what kind of wire I use pretty frequently. Just a few months ago I started using this. This is silicone coated wire. It's incredibly flexible without breaking, super easy to strip, and since it's silicone that it's coated in, it's not going to melt or shrink while you're soldering with it. Really nice to work with. And then this is something that Helder turned me on to. This is VHB tape from 3M, and essentially it's just some incredibly strong double-sided tape. So I'll be using this to attach the 3D printed screen enclosure to the lid of the tin. And that's it for the parts that we'll be using. So if you're ready to see how all this fits together, then let's get started. We're going to be drilling some pilot holes for our micro USB charging port, power switch, and the L and R buttons on the back. And fair warning, it'll probably take 1 or 2 or 5 tries to get this just right. But the nice thing is, if you mess up a tin, it's only a couple dollars wasted and you still get to eat the mints. So for the L and R buttons, you're going to want to drill your pilot holes 19 millimeters in from either side and 4 millimeters from the bottom. And then on the other side, the charging port is going to be 20 millimeters in from the side and about 4.3 millimeters up. That's going to be the center of this. For the power switch, that's going to be 26 millimeters in from the side and about 2.8 millimeters up from the bottom. Getting everything in just the right spot and just the right shape can be kind of tricky. And the reason it's important to get everything in the right spot is, for example, the L and R buttons, they have these braces behind them to kind of hold them in place when you're pressing. And the power switch has these 2 little walls on either side of it, so that'll hold the switch in place as you move it. The power switch, by the way, if you don't use the exact one that I did, you can take some pliers to these and snap them off pretty easily. So if you have one that's not exactly the same size as the one that I used, you'll still be able to glue it in place. So to make this process a little bit easier, I came up with this. And the way that this works, you snap it to the bottom of the tin. You probably want to tape it in place so it doesn't wiggle around. And then you can just use a marker to mark the exact location and shape of each of the holes that you're going to be making. It's especially helpful for the micro USB port because it helps you get it just the right shape. Then on the back for the L and R buttons, you can mark right between these 2 peaks, and that's where you need to drill your pilot hole. It's a good idea to put some masking tape across this so that you don't wind up scratching it up. And then on the inside, I'd recommend putting some tape along the lip here so that it kind of seals it off and keeps any metal shavings from getting caught up in there. Because even though they're really tiny, it's possible that they could come loose and short something out on your Raspberry Pi or on the battery charger, so it's a good idea to try and keep all that out of there. Alright, so starting with the L and R buttons, they need to be about 3.6 millimeters in diameter. But if you use a drill bit that big on them right off the bat, you're going to wind up just tearing up your tin. So what I found works best is to start out with as small the drill bit as you have, and then just slowly step your way up until you get them big enough. And the trick is to hardly put any pressure on it as you're drilling, so it just kind of shaves away at it. And before you even drill your pilot hole, take something like a nail and just gently push in on the exact spot that you need your pilot hole, so you create a small indentation or even a tiny hole so that it holds your drill bit in place. You've got several options for expanding these into their final shapes. If you have a Dremel and some tiny bits for that, that'll save you a lot of work. But the best thing that I found for getting really nice clean edges in exactly the shape that you want is to use some files like these ones. And if you're using the hole guide, you can keep snapping it on periodically to make sure that you're getting the right shape. Alright, so hopefully at this point, after a bit of patience, you've got some nice clean holes on the front for your power switch, your micro USB charging port, and some nice round holes on the back for your L and R buttons. If you want to make sure that everything lines up, you can take this plate that goes in the bottom part of the tin and place your components in there to make sure that they line up. Alright, so that's it for the tin. Go ahead and clean it out, make sure that you get any metal shavings or metal dust out of there. So this part goes behind the screen. It sits in the lid like this. And this is the part that I attach with that tape that I mentioned earlier. The most important part is to make sure that it's completely centered both vertically and horizontally. And fair warning, this stuff is incredibly strong. So once you have it attached, it's not going to budge whether you want it to or not. In fact, if you try and remove it, there's a good chance that you're either going to bend up your tin or even break this 3D printed part trying to get it out. So if that concerns you, you might want to opt for something like some hot glue, or I've even found that this quote-unquote permanent double-sided tape works pretty well. It'll keep it in there for quite a while. You just might need to reapply it if it comes loose. So again, if you don't want to risk it, I'd probably opt for something else. But regardless of what you use to attach it to the lid, the best way that I found to line it up is to take it and set it on the bottom part. Should be just enough of a lip so that it'll stay there. And then once you have it lined up and you have whatever you're going to use to attach it applied to the back of it, just very carefully close the lid and it should stick it right in the middle. And there we go. If you do it right, it should be perfectly centered. So now we're going to get the base put in the bottom of the tin, but we can't attach it to the bottom just yet because if we do that, we're not going to have room to get our tactile switches in there. So we'll go ahead and get our switches ready and get them in place before we attach that to the bottom. Okay, so this wire here in the middle is going to be a shared ground connection. This is going to be our R button, and then this is going to be our L button. So the L button is going to be the one that actually has the ground connection. So you can kind of position them in the tin like that, and then slide the bottom piece into place. Before you glue it down, just kind of press it against the back there just a little bit so that your buttons stick out and you can actually click them. As for actually gluing it down in the tin, you can just put a few blobs of glue in each corner, kind of around the screw posts. And it works really well. I didn't use the double-sided tape for this part because I wanted it to be as thin as possible, so I didn't want any extra thickness below this. But the glue seems to work really well. I haven't had any issues with it. Okay, so we'll put the tin aside for the time being and turn our attention to this guy. What we're gonna do is attach our Raspberry Pi to the board like this. We'll be putting some solder down into each of the GPIO pinholes to basically attach the two boards together. And when they're lined up and attached correctly, it should sit pretty much flush with the camera connector here, and it should be pretty close to the micro SD card slot. Before you go any further though, I would recommend burning a fresh copy of RetroPie to an SD card, putting it in your Raspberry Pi and booting it up just to make sure that it works alright. So that if you do run into problems, you know that you didn't have a dead Raspberry Pi right out of the box. To line these up, easiest thing to do is to put them inside the 3D printed faceplate. There are 3 different sizes of screws that are included with it. The smallest ones are M2 by 3mm screws, and that's what we use to attach the board to the 3D printed part. The next screw size up is M2 by 4mm. Now while you're kind of fusing the two boards together, you want to make sure that the Raspberry Pi is pressed firmly against the button PCB. The best way that I've found to do that is to take a couple of small clamps like this, put one on each side. Just make sure the clamps aren't so strong that you're going to crack something. And what we're going to do is we're going to go down each hole and place a little bit of solder in there, and then stick the tip of our soldering iron down in the pinhole so that it melts and makes contact with the pad below it. And then you can see these labels here above the GPIO pins. Those correspond to these test pads up here that you can use your multimeter to check continuity with to make sure you got a good connection. So for example, this second column here has Y on the top and X on the bottom. We know that we can test that with these pads to make sure that we have a good connection. And this can be a little bit frustrating to do. You might think that you have a good connection, but then you check and you see that you don't, so you need to go back, put the tip of your soldering iron back in there to remelt it, and hopefully make a good connection with the pad underneath it. If you were paying really close attention, you might have seen that I connected a few on either side that I didn't actually need to. I just like to do that to make sure that it's a nice solid connection and it's not going to break if it flexes. Something else that you should watch out for is to make sure that you don't have too much solder sticking up. Like I've got a couple here that are probably sticking out a little bit too far. So you can either go back with your soldering iron and try and take a little bit of that off, or if you have some wire cutters that will cut flush with the surface of this, you can use that to kind of snip it off as well. And you also want to make sure that you don't have any sharp pieces of solder sticking up out of it, because you don't want those to come in contact and potentially poke the battery that's going to be sitting below it. The goal is to make it as smooth as possible. And 2 quick things to note about the button PCB. When you're testing with your multimeter, for the 3.3 volt pin, you're going to want to test with this VCC pin right here. Then the other thing is, I've seen a few people asking about this on the forums already. To get the SD card in and out of the Raspberry Pi at this point, it's easiest to slide it in from underneath. To take it out, you just might have to flex this part up just a tiny bit. And speaking of the SD card, now would be a really good time to go ahead and set that up, put it in your Raspberry Pi, attach the screen, and make sure that everything's working. Check out the written guide for instructions on how to set up your SD card, as well as how to get your Wi-Fi configured before you even put the SD card in the Raspberry Pi. So that way you should be able to set it up without even needing to plug in a keyboard. But for testing it out before we actually put everything in the tin, or modify the sound card like we'll be doing here in a second, I would recommend getting a USB on-the-go cable like this, so that you can go ahead and connect it to your Raspberry Pi and test it out with some headphones, just again to make sure that everything works. To get the screen ready to use, we're going to need to do a couple things real quick. First, it's just a little bit too wide to fit inside the ribbon connector. This is actually meant to be soldered directly to the surface of a circuit board, but to make that a lot easier for people, Helder used a ribbon connector. So all that you need to do is very carefully with the razor trim off a tiny bit from either side of the ribbon cable, making sure not to actually cut any of the metal fingers on it. Then the other thing that we need to do is thicken it up just a little bit so that it stays inside the ribbon connector securely. Alright, so far so good. To test out your sound card, you can plug in some headphones, and then just by navigating the menus within RetroPie, you should be able to hear some clicks as you move the menu items up and down. To actually navigate it, you can just take the rubber membranes from your buttons and navigate that way. Now we'll get the sound card ready to go. It's pretty small to begin with, but we're going to make it even smaller by removing the USB jack, removing the headphone jack, and then we'll also be moving the crystal off of the board. We'll do that by removing it and then attaching a couple of wires to the pinholes where it was, and attach the other end of those wires to the pins on the crystal so that we can move it beside it. So the easiest way that I've found to remove the USB and the headphone jack, especially if you don't have a hot air rework station, is to take some wire clippers and very carefully snip the metal legs on either side of the USB port. And then same thing for the legs on the headphone jack. Be careful as you do that because these pads here do lift pretty easily if you wind up pulling on them. So the goal is to not put any pressure on the actual plug while you snip the metal legs on both sides. And then we'll use the tip of our soldering iron to just heat up those pads all at once, and it should slide right off. So here I'm connecting some wires to where the USB plug used to be connected. If you have different colors of wire, that'll help a lot in keeping track of which wire goes where. From this angle, the top wire is ground, then we have data positive and data negative, and then the bottom one will go to power. So as I said, I'll be using Adafruit's Micro LiPo for this build. It's pretty small as it is, but the JST connector is pretty tall. So we're actually going to remove that, and we'll wind up snipping off the JST connector from the battery and connecting it directly to these pins to make it quite a bit smaller. And the easiest way that I've found is to take some wire clippers and snip these two metal parts on either side. And then this black plastic piece will just kind of slide off. Then we'll be able to heat up these two pins and they should come right off. Just be really careful not to actually pull on them as you're doing that, or you might lift the pads underneath them. Then the other thing that we're going to do, you see these pads here, by default this will charge a battery at 100 milliamps. But if your battery is high enough capacity and can handle it, which ours can, this actually supports charging at 500 milliamps. All we have to do is put a little blob of solder to bridge these two pads here. And then after we do that, we'll be using these two pins right here. There's ground and battery. These two pins will be connected to the button PCB, which will give power to the Raspberry Pi and everything else. Now I get asked pretty frequently what size of wires to use for things like this. For things like buttons, it's okay to use some really tiny wire. I usually use 30 gauge wire for things like that. For things like this that are going to be carrying power though, I use something a little bit thicker. I'm using 26 gauge wire here. And again, this is that silicone coated wire that I mentioned earlier. Very nice to work with. These two wires are going to be going to power the Raspberry Pi. They'll be connected to the button PCB, but you'll notice there's no enable pin on here like there is on the power boost. So what we're going to do is take our power switch and put that in line with the ground wire. And this switch is pretty simple. When it's pushed to either side, the middle pin is connected to the pin on the side that you have the switch pushed to. So we'll be connecting this ground wire to the middle pin, and then we'll have another ground wire coming out of the rightmost pin on here, and that's what will go to the actual pad on the button PCB. I'm going to trim the pins down. We only need a couple millimeters sticking out, and then I'm going to bend them upwards so there's no risk of the battery pushing up against any of those sharp edges. Okay, so the last thing that we need to do with our charging components is to connect our battery to the charger. And since we don't have a JST connector on here anymore, we're going to snip these wires and connect them directly to those pins right there. Now, as I've said lots of times before, batteries can be dangerous. They like to catch on fire and even explode if you don't treat them right. So if you're not very experienced with this kind of thing, you may want to find someone who is to help you out. In other words, proceed at your own risk if you're making this. Now you want to make sure that the wires do not come in contact with each other. So what I recommend doing is doing one wire at a time. You can take the ground wire first, snip it, strip the end, connect it to one of these pins, and then only after that's done, go ahead and snip the other wire and do the same thing. You don't need very much wire, an inch is more than enough. And we'll be connecting those two wires to these two pins that we exposed earlier. Positive is on the left side, that's where the red wire is going to go, and the black wire will connect to the right side. And there we go. Again, be careful doing this, guys. Alright, we can go ahead and put our power related components inside the tin now. I would recommend putting a small piece of electrical tape over the end of one of these wires until we're ready to actually connect it to the button PCB, just so that we don't accidentally short them together on the tin or anything else metal. Now I originally designed this part to be used with a power boost, so that's why this raised brace is a lot further back than the actual size of the charging board. And the reason that I left it set up this way is because a lot of people ran out and bought parts a couple months ago in anticipation of making this. So I wanted it to still work with the power boost. For future batches of this part though, I'll go ahead and slide that forward so it's just the right distance for this charging board. In the meantime, I'll be attaching that to the bottom of this using some more of this VBH tape. And the easiest way to make sure that you line this up correctly is to take a micro USB cable, stick it inside the tin like so, plug it in, and then kind of pull outwards with the cable as you press it down. That should get it nice and flush and lined up. And again, that tape is incredibly strong and should hold it well enough, but if you want, you can reinforce it on the corners with a little bit of glue. Now for the battery, I would not recommend using something as strong as this, but we do want to hold it in place, so we can use a couple small pieces of this tape that I showed earlier. Now the 3D printed part does a pretty good job of holding it in place as you move the switch, but we are going to put a couple small dabs of glue on either side to hold it down. Okay, so that's it for our power related components. Once we actually connect everything, we'll hook up these two wires to the button PCB, which will power the Raspberry Pi and our screen. Alright, so the 3D printed faceplate is almost good to go as is. There may be a couple of things that you need to tweak. The first is the size of the buttonholes. When I was sourcing DS Lite buttons, I tried a few from different manufacturers and there was a pretty annoying amount of variation between the diameters of the buttons. The buttons that I wound up sourcing, and I've been selling along with these parts, were on the smaller side. So I've made sure that all the parts that I've been sending out fit with those. But if you got your buttons elsewhere, or if you took them out of a broken DS Lite or something like that, they may be a little bit too big for these holes. It's not a big deal to fix it, it only takes a minute. You just need a drill bit like this one. And then by hand and very gently, you don't have to put much pressure on it at all. You just press it in there and give it a few turns by hand to make sure you don't go too far. And you can slowly expand it like that and keep checking it with your buttons to see if you've expanded it enough. And we're not talking about very much here. It was only like 0.5 millimeter of variation between the smallest ones that I found and the largest ones. But it was enough that if I had sized these to fit the biggest ones, then the smallest ones would look funny and they'd kind of rattle around in there. So just keep that in mind if you find that your buttons are too tight. The other thing, the way that most 3D printers, including mine, work is they deposit material layer by layer. And so it creates this sort of ridged effect. It's kind of scratchy. And that's normally not a big deal until you have something like buttons that are potentially rubbing up against it. So this part in the middle, which keeps the buttons from twisting around so it keeps the letters upright, what we're going to do is we're going to go around here and very carefully with a razor trim off any blobs that are kind of protruding from it, and then we're going to go in with a file and make it as smooth as we can. And then we're going to do the same for these corners here. So it should only take a minute, but it's definitely worth going to the trouble to do that, because I found that if I didn't do that, then occasionally the buttons would kind of catch on these and it was pretty annoying. Now don't go too crazy filing, just do it little by little and then stop every now and then And place your buttons in there, as well as the rubber membrane. And press it up against something flat and test it out. See, I can still feel a couple of those catching, so I probably need to file it down just a little bit more. But it's really up to you how much effort you put into that. Personally, I prefer to take the time to really get it nice and smooth so the buttons feel nice. The other thing that you're going to want to check to make sure that your buttons feel as nice as they possibly can is the edges of them. Some of them have little bits of plastic sticking out from them, so you might need to sand those down a little bit, and it should help quite a bit as well. And once you're done with that and you're happy with how your buttons feel, you can go ahead and put the speaker in there and get that wired up to our sound card. Now you don't need much glue at all to hold this in place, because we're going to have the button PCB pressed up against it anyway. This is really just to hold it in place so that it doesn't rattle around. You don't need very much wire going to the speakers, maybe 1.5 inches, and we're going to go ahead and connect that to our sound card. We're going to connect one of the speaker wires to this pad right here, which is ground, and then we're going to connect the other wire to this pad right here. But we're also going to bridge this pad with this one. These are the left and right channels. Now normally you'd probably want to put a couple of resistors between these two channels that you're joining together. But since this is so small and it's going to such a small speaker, you're probably not going to notice much of a difference. Now with the speaker as small as this one, it really doesn't matter which one is positive and which one is ground. And at this point we can go ahead and put our buttons in and attach our button PCB to the 3D printed faceplate. Now depending on how thick your screw heads are, you may have to leave off this screw so that it doesn't bump into the micro USB port. It's not a big deal though, everything's held in there really securely with the other screws. Okay, let's go ahead and get this inside the tin. Our sound card is going to sit right here. The edge is going to sit on this raised area. So just a blob of glue right there and we can stick it down. And I'm also going to secure the crystal that we moved right here beside it. Now we can connect our L and R button wires. They only need to reach these pads right here, so we can trim them down a little bit. Okay, so that should be the last bit of soldering that we have to do. Now we can attach our screen. And we're using 4 more M2 by 4mm screws to attach the bezel. Now I would recommend covering pretty much everything metal on the board in something just to protect it from being shorted with the metal tin. Electrical tape should work. Some of that might be a little bit too thick. I've found that Kapton tape works very well because it's nice and thin and it's pretty tough as well. Sorry, that was kind of out of focus while I was doing it there, but you get the idea. Now, after you close it up, it'll be kind of hard to take it apart, so you probably want to turn it on at this point and make sure that everything works. So we've got our controls working, our screen works, and I can hear it clicking as I'm selecting things, so I know the sound's working too. Alright, so you remember earlier when I was setting up the power switch, and I added that big note that said, just kidding, put the power switch on the red wire instead of the black wire. Here's why. With the way that I have it set up now, we're basically connecting and disconnecting the ground here with the ground up here on our controller board. The problem with that is these metal outer parts of the USB ports and the HDMI port are also connected to this ground. So when these come in contact with the 10, it winds up turning the system on because the micro USB port is also pressed up against the 10, which is connected to ground here. So I can fix that here by putting some tape over this, but you wouldn't even have to worry about that if you had put the power switch on the red wire instead. For my other builds, I had been using the power boost, so the switch was hooked up to the enable pin on that, so it didn't matter in that case. So anyway, that's why I need to put the power switch on the red wire instead of the black. Now we need to put the hinge on before we actually close it all up. It comes in two parts, and if you print it correctly, it should just kind of snap together and move pretty freely. The top couple layers on this smaller part are a little bit wider than the rest of them, so it should be on there pretty securely. You should have to pull it pretty hard to get it off. And I know it looks pretty fragile, but depending on what material you print it out of, which this is a polycarbonate blend from Push Plastic, it's actually pretty tough. So the hinge snaps on right here. Then the arm inserts into there. So then as it opens and closes, it moves up and down along this slot here. So to close it up, first try and guide the wires out of the way of anything that's too tall for it to close if the wires are on top of it. And you can use some tape or something if you need to kind of get the wires out of the way of the battery and all that. But anyway, to actually close it up, you can just kind of angle it in there. And it should just kind of pop down there. And it should sit flatly in there, it shouldn't rock back and forth or anything, so you'll be able to feel if you have any wires in the way of anything. And then once you've got everything situated so that it sits flatly in there, then we're going to use some M2 by 8mm screws to hold everything down. And if you did everything right, then it should close completely. And there we go, guys. From start to finish, how to put together a MintyPi using Helder's custom parts. Now, a couple notes about the way that I have RetroPie configured. This is the start button, this is the select button, and if you hold down the select button and press the L and R keys, it'll turn the volume up and down while you're in a game. Pushing start and select together takes you back to the menu, just like any other RetroPie setup. And then the other thing that I've added, if you go to the RetroPie menu and you scroll down, you'll see a couple of options for turning Wi-Fi and Bluetooth on and off. So if you turn those off, you should get about half an hour or so of extra battery life. Takes a second, but then you'll see a message saying that Wi-Fi and Bluetooth have been disabled. I think that's about it, guys. Now I'll have another video pretty soon that'll show you how to put together one of these using the 2.2-inch screen that you can get on eBay for pretty cheap, as well as using some copper tape to make your own button PCB, sort of like I did for the X and Y buttons in the original Game Boy Zero guide that I did. So if for whatever reason you aren't able to get a hold of Helder's parts, that'll be an option for you soon as well. Be sure and check out the written guide where I'll go into more detail about things like setting up your SD card, setting up your Wi-Fi, all that good stuff. And also be sure to stop by the forums where other people will be sharing their build progress, sharing ideas, and helping each other out. Thanks for watching, guys, and I'll see you next time.